So today we want to build on where we ended yesterday. We ended looking at the concept of radians. And remember, radians are simply a different unit of measure to measure angles with. Just like we have inches and centimeters to measure lengths, we have radians and degrees to measure our angles, okay? We discussed this briefly yesterday. You know, 1 radian is the measure of the central angles that make the arc length equal to the radius. So we saw that circle, and we have this radius r. Okay, if we cut off a piece of the circle that's the same length as r, if we were to straighten it out, then the angle that would form in the middle of the circle would be 1 radian. Okay? 1 radian. And we noticed here that pi is 180 degrees. So today what I want to look at is actually converting from one unit of measure to another. Okay? The nice thing is the mathematics that we're going to do is the same as we would do for any other unit conversion. All right? If I were asking you to convert from, say, feet to inches, you say, okay, well, there are 12 inches in 1 foot, so I'm going to multiply by that, that ratio to do the conversion. Here, we have a conversion that pi equals 180, so we're either going to multiply by pi over 180, or we're going to multiply by 180 over pi. Okay? And it all depends on what we want to convert to. If you want to end up in radians, you put the pi on top. If you want to end up in degrees, you put the 180 on top. Okay? So let's look at how this works. All right? Relatively simple from a math standpoint. Well, let's look at it. 36 degrees is how many radians? All right? I want to end up in radians, so I'm multiplying 36 degrees by pi radians over 180 degrees. Okay? Now notice here that our degrees cancel each other out. Okay? This is one way you set the proportion or the ratio up right. The unit of measure you don't want should cancel out. So now we just have 36 pi over 180. And one thing I want you to do on all of these, if you have a pi in the original, I want you to leave them in terms of pi. Okay? Leave it in terms of pi. So here, I'm simply going to reduce the fraction 36 over 180. Okay? So if I reduce that, let's see, there's a 6 in there, so I'd have 6 pi over 30. Okay, that's pi over 5. So pi over 5 radians is the same as 36 degrees. Okay? And we need to get used to seeing angles written like this. Pi over 5, pi over 6, pi over 3, pi over 2. We're going to be using that kind of a measurement a lot. Okay? Any questions on that conversion? All right. Let's do our next one, okay? We've got 12.56 radians. I want to convert that to degrees. So what am I multiplying by?
180.
Good. 180 over pi. All right. So notice here, and I'm writing out the units on all of these just to show how this works. Notice the radians cancel out with the radians. Okay. And I've got, this one we'll use our calculators for a bit. We have 12.56 times 180 divided by pi degrees. So if we use our calculators here, we have 12.56 times 180 divided by, and you need to find the pi button on your calculators so you have exact. It's actually above the exponent button. If you hit second and then that little caret symbol, this on the calculator on your TI-83 and 84, okay, you'll see the pi button there. But if I divide this by pi, I get 719.63 if we round to 2 decimal places. Okay? So 719.63 degrees. Okay? Does that make sense? Okay. Now, question, or just, I want to point out something. Remember that pi is approximately 3.14. So if I have 12 point something, approximately how many pi's do I have? Approximately 4. 4 times 3 would be 12. So if I'm at 12.56 radians, I'm about at 4 pi, which would be how many degrees?
720.
Yeah, 720. So does my answer make sense?
Yes.
Yeah, it does. Okay. So, any questions so far? All right. So let's look at kind of an extension of this, okay? And there's a little bit of notation that you're going to need to be familiar with, but here's a new term, and that is arc length. You may have done a little bit with arc length in geometry. Did some of you guys do that in geometry, arc length? Okay. Did you use a lowercase s for arc length? Okay, it's okay if you didn't, but just, we're going to use a lowercase s to represent arc length. Depending on what book you look at, it'll be different. But there's a proportion here, okay? Now let's make sure we all understand what we're talking about when we're talking about arc length. Arc length is not a distance in a straight line, it's a distance along the circle. Okay? So think of it as though you're running along this circle. If you were to start here and run along the outside of the circle, you're running on an arc, okay? So S here would be the arc length, okay? Now, that makes it a little bit of a challenge to measure, okay? So what we recognize is we say, okay, this arc length is part of the whole distance around the circle. What do we call the whole distance around? The circumference, okay? Yeah.
Wouldn't S just equal 70 degrees? Like 70.
Well, here's the thing. The degree is the measure of the central angle. We want the actual distance, which I could have a 70-degree angle, but depending on how big of a circle I'm dealing with, I'm going to have a very different distance. Okay, so here what we have is this proportion. I like this proportion because it's really easy to use. We have the radians over 2 pi, okay, or the degrees out of 360. And what we're talking about here is this central angle, okay? So the central angle out of the full circle is what we're working with right here. It's either in radians, so the full circle is 2 pi, or it's in degrees, and the full circle is 360 degrees. So essentially, guys, if you think about it, we're finding the ratio of the circle that we're dealing with. And then that's going to equal the same ratio of the arc length to the entire circumference. Okay? 2 pi r is our circumference. Okay? You can use pi d as well, but we're typically given the radius instead, but there's our circumference. Okay? So we're just setting up a proportion. And in this case here, we're in degrees, so we're going to put 70 degrees out of 360 degrees is going to equal the arc length out of the full circumference, okay? So 2 times pi times the radius is 5.5. Okay?
Do we keep this answer in terms of pi?
It kind of depends on the application. If it doesn't have any kind of a context or something, you can do that. Typically the problem will tell you either round to so many decimal places or give, if it says, everyone listen to this here, anytime you're told to find the exact value or the exact angle, you're leaving it in terms of pi, so there's no rounding. Okay? Later on we'll deal with stuff where we have radicals, and anytime you see, give the exact value of the sine function or cosine or whatever it is, they're going to have you leave it in terms of the radical. Okay? So in this case, if we leave it in terms of pi, we've got 11 pi in our denominator. If I multiply both sides by 11 pi, okay, I get the arc length equal to 770 pi over 360, okay, which is 77 pi over 36. That doesn't reduce, so I could leave it there, or I could figure out that as a decimal, 77 times pi divided by 36 is approximately 6.72.
Sorry, where'd you get 11 pi?
2 times 5.5 pi. Okay. Right. So our arc length is then approximately 6.72 centimeters. Okay? So we're able to find that distance along the arc. We know how far we've traveled here by using the proportion. Okay? Any questions? Okay.
I'm getting a 0.6.
You're getting a 0.67?
Yeah.
Are you using 3.14 or are you hitting the pi
I'm
button?
hitting pi.
You are hitting the pi button?
I got
Wait.
the same thing.
77 divided by 36 times pi should be 6.72.
I got 6.7.
Yeah, because I did that other one, I did 778 and then I did 6.
Okay. All right, so we can use this if we know the distance. All right. Let's say though, think about some of the applications here. Okay. Let's say that you are designing a machine that you want to do something. So, and you have this one arm that's controlled by a pulley, and you need the arm to move a certain distance. Well, the arm might be moving a certain distance, but you've got to wind the pulley so that the arc length equals that distance, right? That's kind of what you could do. And what you would know then in that case is you already know what the arc length you want is. You have to know what to program the machine to do as far as how far to rotate. Let's take a look at this example here. Let's say that we had this pulley that has a 12-inch radius, okay, and it's attached to some part in our machine, okay. Well, I need to move that part 38 inches total, okay. So I need to be very precise. If I need to move it exactly 38 inches, I gotta be precise in what angle I program my machine to rotate through. Okay? So I've used the Greek letter theta here to represent the angle. Okay? And here it says that we need to do it in radians. So I'm going to set up a proportion, and I say, okay, I want my angle out of the full circle 2 pi to equal the arc length 38 inches over the full circumference. Okay? What would the circumference be here?
24 pi.
Good, 24 pi. 2 pi r is 24 pi. Okay? So, if you notice here, I can solve this simply by multiplying both sides by 2 pi. Okay? And I get theta equal to 38 over 12. Okay, the pi's cancel out, the 2 cancels out the 24 and leaves a 12. So I have 38 over 12, which is 3 1/6 radians. Okay? So when I'm programming my machine, I need to tell it to rotate that pulley exactly 3 1/6 radians in order to move the part that I'm trying to move exactly 38 inches. Okay? If you think about how many machines are designed to move things using pulleys and things like that, you can see, you know, this is used in the programming of lots of stuff. Okay? All right. Any questions on arc length? All right. This brings us to a concept I just want to touch on. One of the things that we can also calculate here is a speed. Think about it. When you're measuring speed, you do distance traveled divided by time. Okay, and that's pretty easy to do if something's moving in a straight line. But in this case, if we're trying to find out how fast something's moving around a circle, the distance is going to be an arc length. Okay? So you see here, linear speed is, you know, arc length divided by time. So let's say in that previous example, we needed to move that arm at a given, you know, within a certain number of seconds. All right? So let's say we needed to move it that 38 inches in 2 seconds. Our linear speed would have been 19 inches per second. Okay? So it's a pretty simple concept, but I just want you to see this as another application. Another thing we can tell is how fast the angle is changing. That's kind of an interesting one here. How fast the angle is changing. And here we have the central angle divided by time, the angular speed. Okay? So we have this arc length, S. You have to know what the central angle is divided by time. Okay? So let's take that same previous example. What was our radian measure for the central angle? 3 1/6. Okay. So the angular speed in that case would be 3 1/6 radians for every 2 seconds. All right. Well, if you simplify that, half of 3 is 1 1/2, half of a sixth is 1/12. So that would be 1 6/12 plus 1/12 would be 7/12. We're moving at a rate of 1 7/12 radians per second. Okay? So, linear speed is how fast the actual object on the outside of the circle is moving. Angular speed is measuring how fast your angle is changing. So, kind of a cool application there. Okay? And this is something we may take into account. For example, if we have this part moving within our machine, but we know that if we move it too fast, then it might break, okay? We would need to test this as well. So the engineer might, check out the speeds that are going to be involved to do the job they want to do. Okay? All right.
Yeah, sorry